Okay, so shift encrypt, you're taking an initial message and you're shifting it by a certain value. So by shifting it, I mean like, say like you have A is 1, B is 2, and so on through the alphabet. So you're shifting by like, say 3. So A is 1 plus 3, you get 4. So A would map to D, and so on for every character. I do this by using a string buffer. I cycle through every character in the initial message to shift it by that certain amount. Then whatever value you get after you shift it, I insert that into the string buffer at the same index. So yeah, that if statement there is just accounting for symbols because we don't want to change those. The else, I did not mean to scroll down that far. The else ifs that you see here are just making sure it wraps around. So like if you want to shift z by 1, you basically end up with a 27, so you have to like subtract by 26. I mean, the Unicode values are different, but that's basically the idea. So you wrap around the alphabet instead of having an error. Then this at the end is just converting basically everything to uppercase that needs to be. So like capital letters stay capital even after you convert them. The mirror encrypt is very similar to shift. I literally use the same algorithm. So like A to Z is a mirror encrypt, that's 25. B to Y, you're shifting by 23. C to X, 21, and so on for the entire alphabet. So all this code is really doing is like saying if you have this character, shift by this much. And I use 2 because when you get halfway through, the shift value is going to be negative, and you just have to account for that. And yeah, so this also uses a string buffer, so you go through one character at a time, do the shift encrypt, and map it to the correct one. Then at the end, this is also, I think, just mapping the capital letters to the right place again.